Imagine this. Every single person on planet Earth, nearly 8 billion of us, gathers together in one place. With a synchronized countdown, we all jump into the air at the exact same moment. Would it cause a global earthquake? Could it knock the planet off its axis? Or would nothing at all happen? Today we're going to break down the science of this hypothetical global jump and find out whether it would create a world-altering event or just a massive, underwhelming hop. Let's start by crunching the numbers. The current population of Earth is roughly 8 billion people. On average, an adult weighs around 62 kilograms, while children and teenagers weigh less, bringing the average human weight down to about 50 kilograms. So, if we multiply 8 billion people by an average of 50 kilograms, the total mass of humanity would be around 400 million metric tons. That sounds massive, and it is, but how does it compare to Earth itself? Earth weighs approximately 5.97 x 1n24 kilograms. That's nearly 6 septillion kilograms. Compared to the planet, humanity is essentially a speck of dust. But what about the force we create when we jump? When you jump, you push against the ground with a force equal to your mass times acceleration due to gravity. On average, each human generates around 2,000 newtons of force during a jump. If 8 billion people jumped simultaneously, the combined force would be around 4 quadrillion newtons. Sounds powerful, right? But in reality, this force is tiny compared to the gravitational binding force of the planet. Even the largest earthquakes, like the 9.1 magnitude Indian Ocean quake in 2004, released energy equivalent to around 4 exajoules, far more powerful than our collective jump. So, would the jump cause a global earthquake? No, not even close. Now what about the idea of shifting the planet itself? When we jump, we push downward. But Newton's third law of motion states that for every action, there's an equal and opposite reaction. So wouldn't Earth experience a tiny push in the opposite direction? Technically, yes, but here's the catch. Earth's massive inertia makes it practically immune to such tiny forces. The collective jump would move the Earth by a microscopic distance, around 1/100th the width of a hydrogen atom, completely imperceptible. What about the oceans? Would our jump cause a tsunami? Nope. Even if all of us jumped on the same side of the planet, the minuscule shift would be dwarfed by the regular influence of the moon's gravitational pull, which creates ocean tides. The moon's gravity is 2 million times stronger than the force of our combined jump, so no tidal waves or flooding would occur. And the atmosphere? While a massive synchronized jump might create a localized compression of air, it wouldn't be enough to trigger any large-scale weather changes or windstorms. Oddly enough, the biggest effect wouldn't come from the jump itself, but rather from the logistics of gathering everyone together. To fit 8 billion people in one location, we'd need an area about 500,000 square kilometers, roughly the size of Spain or Texas. The concentration of heat, carbon dioxide, and waste would create an environmental catastrophe. Food, water, and waste management would become impossible. And once the event is over, dispersing everyone back home would take years. What if instead of one massive group jump, we all jumped individually at random times over the course of a day? Surprisingly, the result would be no different. Earth's rotation is driven by the gravitational interactions with the sun and moon, not by our minuscule movements. Even if we all jumped in perfect sync, Earth's rotation, orbit, and position in space would remain completely unchanged. So, what's the verdict? Despite our combined mass and the synchronized force of billions of people jumping together, the Earth wouldn't budge. There would be no earthquake, no tidal waves, and no change in Earth's orbit. At best, a few seismometers might detect a faint tremor, but nothing more. Ultimately, while it's fun to imagine a planet-shaking leap, the reality is far more grounded. When it comes to physics, even 8 billion people are no match for the sheer scale of our planet. So, keep on jumping for fun, for exercise, or just for the thrill of it, but if you're hoping to shake the world, you'll need to come up with a far bigger plan. If you enjoyed this video, hit the like button, subscribe, and share it with your friends. Let's keep exploring the science behind the impossible.